Hey, I'm gonna try and keep this as quick as possible. Tomorrow is my final for my intro to matrices and linear algebra exam. I've always been thinking of it as an intro to matrices exam. I never actually considered the linear algebra part, which now I'm realizing like I'm doing linear algebra. It's kind of fun to do. But for some quick context, it's the end of the year. And personally, I don't think I really understood a lot of the class. So like over the past couple of weeks and days, I've just been like intuitively studying. And the last 2 days are when I started like tackling the more advanced topics. So stuff like eigenvalues, eigenvectors, eigenspaces, orthogonality, orthonormal, orthogonal projections, orthogonal bases, orthogonal compliments. I'm lucky because there's some stuff they cut from the exam, which I'm really happy about because they're not going to cover that. So as long as they stay true to their word, it shouldn't be so bad. Percy being very pragmatic, um, accounting for like the amount of mistakes I make during practice and the lack of practice I've done, I think I'm looking at a D to C. I don't think that that's just me being pragmatic. If I was just looking like if I was like look at if I was to abstract it for myself and give it to like someone else and just see like their experience so far with how they've been practicing and studying, I think DCC is a fair grade. But I'm really hoping for an A. Yeah, really hoping for an A. I think what really is going to be the distinction there is just doing some more practice. I think I have the topics down to a somewhat okay T. I think what really is choking me in this right now is that sometimes I mess up like on this like cause I just been studying like for the whole day. Like I stayed up to like 6 a.m. studying, then woke up like 11, go back to studying. But I think I've been like absorbing too much or just looking at it too much. And I think that's kind of what's messed me up a bit. I also think it's a matter of really just not just like the word sometimes since I'm like rushing to study this a lot of like the because with different sample exams I have like different ways of phrasing the question. I think that's what's messing me up in terms of like okay I don't know what method to use, but I think what I did now because it usually happens when it comes to the orthogonal subtopics. So, for example, just to give an overview, like you have orthogonal complements, you have orthogonal projections, you have orthogonal bases, which is like you have to use the Gram-Smith method, and like they're all very different. I think the ones that really I mix up a bit is the Gram-Smith method and the orthogonal projection. Because with the Gram-Smith method, what you have to do is that you have to subtract, and that's important because like you're subtracting, but the projection is a similar like for the oh my days. For the components of the equation, it's similar because like you still have to do the dot product of the I guess the vector and then the orthogonal I think it's orthogonal, maybe the orthonormal vector of so whatever, right, of the previous vector. But then with the projection you just add and keep on adding. So I think that was something interesting I had to that was confusing me a bit. But now I have written on the board, I can try and memorize it in my head. Um, there's some stuff for diagonalization, but I think diagonalization is okay. Like eigenvalues is really just factorization. That's like the most important part in my opinion. Then the eigenvectors I get a bit confusing, but I think with eigenvectors, once you get there, you just have to do the reduced row echelon form and just be like, okay, I have reduced row echelon form, system of equations, plug that and get the stuff. My eigenspace, blah blah blah. Nullity plus rank equals the number of columns. But yeah, I think it's really interesting. I think I'm hoping not to mess up with eigenvectors. I know they can be a bit tricky. I know they can throw me off. I know like even when it's like basis of row A and basis of column A. Fun fact, not fun fact, but like for me, so for the basis of column A, what really happens is that once you get like the reduced row echelon form, or I guess reduced or row echelon form, whichever one you want, you actually just take the column that has the pivots. You find the where you locate the columns and you go back to the original matrix and you take the columns from there. But with the rows, you have to actually take it from the reduced row echelon form of the matrix. So I think that was something that was really interesting. And then for basis of null, that's just when you get like the eigenvector. No, I think that's when you get the eigenvectors. I think basis of null is eigenvectors, I believe. Okay, yeah. So no, that was actually wrong. What I said before. I think what I said before was that the eigenvectors and the null space, same thing. That's not true. What was confusing with is like it's the same method to get them. With eigenvectors, we really have to just like plug in the eigenvalues you get, which aren't too crazy to get. But when you once you get that, you have to do like the same method of like saying like it's saying the matrix equal to zero and then system of equations, all of that. Same thing with eigen. Doing reduced Rutherford form. Same thing with the null space, but you don't have to like get the eigenvalues and all that. Just like set equal to zero with your reduced Rutherford form. Um, but yeah, I think actually I kind of want to see how much more I can like babble on about related concepts. I do think it's kind of fun. Matrix operations, fun. Solving linear systems, reduced Rutherford form, linear independence, not too crazy. Subspaces, basis, dimensions, and rank. Rank is still confusing me, to be honest. I think because here's the thing: nullity, if I remember correctly, is the number of independent. Like once you do the null space, you just take the dimensions of the null space, and then rank might be. I think rank is independent vectors, but then okay, I think it's because I'm working with 4x4 matrices because I think a lot of times they're the same. How do you find? Let me just ask. And the trick about like, because sometimes I've been using AI for a lot of this study. And I think that's like one. I hope that's not my downfall, but it's very troublesome because there's times when I get really confused and I start tracking that. Like I start realizing something's off. Then I go back. I was like, "Did you mess this up?" Then I'll say no at first, and then I ask again. I'm like, "Yeah, I messed up." Like I being the AI. I think that sucks a lot. So what I've been doing, because that's what I was doing for the past couple of weeks or so. So now I've been transitioning to like doing a more hybrid method of using like actual videos and using ChatGPT or Gemini to help do the teach like give me a brief overview of the concepts, how to find nullity versus rank. Okay, nullity dimension of null space. Yeah, how many free variables are in the solution? Ax equals 0. Rank is the number of independent vectors. Okay, so yeah, that's why I'm confused because the way I'm seeing it. Okay, I think I understand. Because with rank, you just do row echelon form and you count the number of pivot columns, I guess, and the nullity, you start to do those stuff, but then you set equal to zero and all that. Okay, so that's not too crazy. What else is there? Inverse matrices and matrix power is something that I'm really happy I just did this video on because I would probably have skipped that, and if I saw that in the exam, I would honestly probably skip the question and make some math up when I come back to it. So I think matrix power is something I have to get down. Inverse matrices, 2 by 2 is really just 1 over AD minus BC, and then you times it by the matrices. But the fun thing is that you swap A and D, and then you make B and C negative for some reason. That's for 2 by 2. But that doesn't really matter because like for the ones I'm seeing on the sample exams, it's 3 by 3 or more. And what you really have to do is just set equal to the identity matrix, and then make the non-identity matrix be equal to the identity matrix by doing some elementary row operations. And then once it is, like while you're doing those elementary row operations, you do the same thing to the identity matrix. And then once you're done, and the non-identity matrix now is an identity matrix, you take the other side, and that is your inverse. Fun, like it's okay. I just don't like because a lot of the times like it's like doing like reduced Rutherford form, like doing those elementary operations, but it's like you have to do it for two stuff, and it kind of gets annoying. But yeah, I also don't really like fractions when I'm doing reduced Rutherford form, even though it's kind of like the cheat to do it, in my opinion. Orthogonal basis, complements, projections, and Gram-Schmidt process. So I have those down to a rough T, I think. And then before I take the exam, I really hope to do some basic calculations of my matrix operations. Because once again, respect for the fundamentals are everything in my opinion. Because last time I did, like when I was doing my calc exam, I think calc 1, calc 2, I think I studied, like I was really worried about the advanced stuff, but I skipped like the fundamentals. And like since I think maybe I'm an actions person, once I notice something's off by a bit, I question like all the foundational stuff. I'm like, dang, you actually have to add numbers or multiply them, and just got charged. Oh my days. I'll deal with that later. But yeah. I think it's gonna be a really amazing exam. I pray again A. I really do think it's fun studying. And yeah, I think It's just a matter of continuing to study. I've kind of taken way too long to do this video, but I do think it was helpful. I think I'm really glad I turned this video into a way to benefit my student by just like blabbering on this kind of thing. A process my history teacher in freshman year taught me, where it's just like when you have an exam come up, just like say everything, you write down everything you know about the topics. It kind of gets your brain running and starts to realize like the patterns, or just it gets your brain thinking. Like it kind of like demystifies a lot of the blurry air sounding the topics. Because once you speak out, it actually makes sense. I think that's the logic behind it. I don't know if she ever explained the thing, but it was really helpful, so I'm glad I'm doing it now. But besides that, I have nothing else to say, so have a great day.